All right, so we did some writing of, we did some equation of a line, right? What was the first thing? We didn't really do anything with it. Do you remember what that first form was? It was ax plus by plus c equals 0. Remember writing that down? What do we call that thing? Standard form. We haven't really done anything with that, have we? Let me see. But we will on this lesson, all right? I don't know why they introduced it on the other one and then we do it on this one. But anyway, that's all right. So we will do a little bit of that standard form. And then there's another form that we're going to do, and it's called the point slope form. All right, so let's do that first. And where we get the point slope form, well, actually, they give you an example first. Okay, I see what they're doing. They're just kind of showing you. Yeah, let's just do the example first, and then we'll do the point slope form thing. The point slope form can come in handy sometimes when they give you a point and they give you a what? Slope, right? When they give you that, then the point slope is kind of nice. Now here's a situation where they give you a point, they give you a slope. Now right now, we don't know the point slope form, okay? We haven't learned it yet. But we did it in geometry. I keep saying that. But let's just say they give us a point, 2, 1, and they give us a slope, 2/3. And what you want to do is you want to write the equation of a line. So we're not just graphing this. It's a little different than the last lesson. The last lesson, they give you equations and you just have to graph them. Would you agree? This time, they're going to give you some information and they want you to write the equation of the line. All right? And we're going to write it in slope-intercept form. Okay? We're going to write the equation in slope-intercept form. Now you have to read the problems carefully, because sometimes they're going to say put your equation of a line in slope-intercept form. Sometimes they're going to say put it in point-slope form. Sometimes they're going to say put it in standard form. All right, we're going to hit both of those other ones today. But this is the one we're familiar with. All right, is the slope-intercept form, which is what? Y equals, yep, mx plus b. All right, so how in the world do we take this information and put it into this formula right here? Well, obviously, what are we going to put in for that m? 2/3. Yeah, because they tell you the 2/3. Here's the part that some students get a little mixed up on, but hopefully we'll clear it up. This is a point. What's the first part of a point? The x. What's the second part of the point? The y. All right, so do you see an x and y here? So guess what's going to go in for the x? Well, give me the number. The 2, and what's going to go in for the y? So they give you 3 of the 4 things, don't they? They give you an x, they give you a y, they give you the m, the slope. And what do you think you're going to find? The b. That's right. So we're going to put all that stuff in here, solve for the b. Once we get the b, then we can write the equation of the line, because we already know the slope, right? So the only thing we're missing is the y-intercept, which is the b. Does that make sense? Okay, so let's do it. It's really not that bad. It's just substitution, right? We just plug stuff in. So what is the y? 1 equals m. What is the m? 2/3. What is the x? 2, right? And we multiply it, right? The m times the x, so we multiply them together, plus the what? The b. Now, let's work this thing out. That's 1. How do I multiply these together? That's right. Just multiply straight across. 2 times 2 is 4/3. Yes? Right pass. Everybody good? So now I just got to solve for b. So how do I get b by itself? Minus 4/3. So I minus 4/3. How do I minus that from a 1? Make that a 3/3, right? Common denominator. Everybody with me on that? And then, so I got 3/3 minus 4/3. What's that? Negative 1/3. All right, so b equals negative 1/3. Now we put it all together because they want you to write an equation in this form right here. So we just write the x as an x and the y as a y. Okay, we replace the m and the b. So I just write this y equals m. What's the m? Yeah, that was easy. I already told you at the beginning. That was 2/3. And then you write the letter x, and then you put the b. What did we find the b to be? Negative 1/3. So we put minus 1/3. So there you go. So that is the equation of a line that goes through a point, and they tell you the slope. Make sense? All right. There's another way to do this. You could do it that way, and that's perfectly fine. All right, but there's another way to do it. And what did I mention the name of it was? Point what? The point slope form. And it's actually pretty easy where it comes from. So I'll show you that. It comes from the definition of the slope. Remember that? Slope is the change in y over the change in x. But how do we write the change in y? y2 minus y1, correct? Over the change in x, which is x2 minus x1. Okay? What we're going to do, the point slope form doesn't have just one letter at the beginning, like slope intercept's got y equals, right? This one, what we're going to do is we are going to solve just for that, which actually makes it pretty easy. It doesn't matter. It doesn't make any difference if you go y1 minus y2, as long as this would be x1 minus x2. All right? Everybody understand that? So I could have gone either way. I could have said y1 minus y2, but I would have had to make this x1 minus x2. So what we're going to do is we're just going to solve for this. So really, there's only one step that we have to do to get our point slope form, and that's to get rid of the denominator. How do I get rid of something that's being multiplied or being divided? Gave it away. I multiply it. That's right. So if this is being divided by x2 minus x1, how do I get rid of it? I multiply both sides by x2 minus x1. So that gives us y2 minus y1 equals m what? How do I get rid of this? I multiply it. So it's times x2 minus x1. I just didn't show the step, all right? I know I'm supposed to show my work, all that kind of stuff, right? But it just gets a little messy, right? I could put times x2 minus x1, they cancel out. Multiply that by x2 minus x1. There you go. And we're not going to divide it out. We're not going to distribute. That right there is the way they write the point slope form, right there. And it's pretty simple how they got it. How'd they get it? They took the definition of a slope and they just solved for y2 minus y1. Pretty easy, right? Yep. So now, how do we use this? Well, let's do the example. What we're going to do is we're going to use this to put our numbers into, and then we're going to write our answer in standard form. I'll tell you what, since we're going to write our answer in standard form, let's write that down right now before we start this thing. Do you remember what standard form was? Yeah. Plus c equals 0. Now, there are sometimes some authors, some people will say it's ax plus by equals c. But this book says plus c equals 0. So that's how we're going to do it, okay? Everybody with me? Now, you may have no idea what that means, but we're going to get there in a second. We did talk about it a little bit. What did we say had to be true about the b and the c? They have to be, what is that? What kind of numbers? No, they're all real numbers. Every number we deal with is a real number. No, not even positive. Was it you guys that we talked about this? Because I'm doing equation of the lines in geometry and in pre-calc. So all three of my honors math classes, we're doing equations of a line. And I'm getting mixed up on when I said what in what class. Anyway, these have to be integers. I didn't say that in here? Okay, well, I'll say it now. These have to be integers. What's an integer? Well, negative and positive, but they can't be fractions, can't be decimals, okay? They're kind of like whole numbers and negative whole numbers, right? So they're all the whole numbers and all the negative whole numbers. But you can't really say, technically, some math teachers would flip out if I said that because a whole number can't be negative, but you get the idea, right? You get the idea. All right. This right here, the A, has to be positive. And it also has to be an integer, but more importantly, it has to be positive, all right? So which means what? If you write something in standard form, you can't have any what in it? You can't have any fractions, that's right. Okay, so no fractions, no decimals, and the A, the first letter, the one with the X, has to be positive. Everybody with me? All right, so let's do a problem. This is example 2. Let's see, they give you the same thing. In fact, this is the same exact problem that we just finished doing. All right, they're just showing you 2 different ways to do it. All right, and another form to put it in. So it's the same exact numbers. So it's 2, 1 for the point, and the slope is 2/3. All right. So now, how do I use this? To tell you the truth, this may be a little bit easier. It may not be easier. I'm not really sure. Let's just see how it works out. All right. I'm sorry. Let's do this. Instead of y2 minus y1, because they don't give you 2 points here, do they? This right here is how they're going to give it to you. All right, that's the slope. It came from that, which is the y2 minus y1, but this y just stays y. You're not plugging in anything to that. Okay, what do you plug in the x and y into? The ones, the y1 and the x1. Okay, everybody see that? All right, so we're going to take this. So on the other problem, we said this is x and y, but on this one, that's x1, y1. And you're just plugging stuff in. You're keeping that y a y. You're keeping this x, what? An x. Make sense? So let's do it. Y minus y1. What's my y1? It's just 1. Equals m, which is 2/3, times x, that just stays x, minus x1. What's my x1? It's a 2. Okay? Now, that does not look like it's in standard form, does it? Let me show you a little trick. What bothers you about this equation probably? The fraction, obviously, okay? That's what usually bothers everybody. I'm going to show you a little way to get rid of that fraction that makes this a little bit easier. Everybody watching? Okay? You haven't lost me yet, have you? What about this actually makes it a fraction? The 3. Okay, the 3 makes that a fraction, the denominator, correct? So I want to get rid of that denominator. So what I'm going to do is I'm going to multiply that by 3. Wouldn't that get rid of it? Yeah, because it would cancel it out. Now I can't just randomly multiply one side by 3. What do I have to do to the other side? Multiply that by 3 as well. So I'm going to take this, that whole side, that's why I put in parentheses, and multiply it by 3. Now, multiplying just the 2/3 by 3 is multiplying the whole entire right side by 3. All right, a lot of people think you have to multiply the... A lot of people think you have to multiply this by 3 and the parentheses by 3. But since they're being multiplied together, for instance, if I said I had 3 times 2, and I wanted to multiply that by 5, do I have to multiply the 3 by a 5 and the 2 by a 5? No, just either one of those by the 5, right? So I could just go 15 times 2, and I've multiplied it. It's the same thing here, okay? A lot of students get mixed up on that, so I always like to talk about that. All right, enough of that. Let's keep going. Whoops. We can distribute through here. So what's that? 3y minus 3 equals, what happens here? Cancels. Let's go ahead and distribute now. We can do that in our head, can't we? What's that? 2x minus 4. See what I did? Just multiplied everything by 3. So I distributed that 3 through this. The 3 canceled out, left me with a 2 outside the parentheses, so I distribute the 2 through there. Now, what am I trying to do? I am trying to make it look like this. So I want the x, y, I want everything on the left-hand side, and I want to set it equal to 0. So let's do that. Let's throw everything to the left-hand side. So how would I do that? Subtract a 2x, so I'm going to get a minus 2x, correct? And then do what? Add a 4. Add a 4. So I got my negative 2x on the other side. I got that 3y. I'm going to put that next. What's this going to give me? Plus 1 equals 0. That looks like it's in standard form. I don't have any fractions. I don't have any decimals. But what's the problem? X is negative. That's right. You got it. So how do I get rid of that negative? Okay, I could divide it by a negative or multiply by a negative. Either way, right? So what's that going to do for me? If I divide or multiply everything by a negative, what's that going to give me? Positive. What's it going to do this? Make that negative. And what's it going to do to this? Make that negative. I do it to the other side, but multiplying by a negative to 0 is just 0 anyway. Now, does that look like this? Absolutely. And that's what they want. That is in standard form. Okay? Now, if you were to do that with this, right, change that into standard form, that might be a little bit uglier. It really wouldn't be all that bad, right? Because I could have just multiplied everything by a 3, then moved everything over. It really, like the amount of work involved in either one of those is pretty much the same. I don't think any way is like easier or more difficult. It's just different. It's just a different way of doing it. And that's what they want you to do. All right, let's see what else we got. And you got to read these problems carefully. This one says, this is example 3. This says, write the slope-intercept form. So now this time we're going y equals mx plus b. Make sure you read the problem before you just look at the numbers. Make sure you look at the problem and see what form you want to write it in. So what's my answer going to look like? It's going to look like y equals mx plus b. That's what this one's going to look like. Now look what they tell you. They don't give you a point and a slope anymore. They already did that for example 1. They just give you 2 points. And you got to find the slope. Very good. Negative 4, 3, and 2, 6. So they give you those 2 points, and what you have to do is you got to write the equation of a line, right, that goes through those 2 points. So, just like Natalie said, let's find the slope, right? Let's find the slope. So we should be able to find the slope, right? We know how to do that. Changing y, we're changing x. Subtract the y's, subtract the x's. So let's do that. Let's go. You can go 6 minus 3 or 3 minus 6. It doesn't matter. I'm going to go 3 minus 6. And then the bottom, you got to go in the same order. So if I go 3 minus 6, what do I have to do here? Negative 4 minus 2. All right, let's see what we get. We get negative 3 over negative 6, and that becomes what? 1/3. So now I only had to do one extra step compared to example 1. So now I have a point, I got a slope. In fact, I got 2 points. What is that? It's 1/2. Like I said, it was just the marker that wrote that wrong. You don't believe me? Okay, so it's 1/2, not 1/3. So that's 1/2. All right, so that's my slope. It's not my answer, but it's half my answer, isn't it? Now all I got to do is find what? The b. All right, so let's do what we did before. Let's just plug in an x and a y and an m and solve for b. All right, so now the problem is not a problem. It's actually kind of a good thing. I could choose either point. It doesn't matter which point I pick. You could choose them either one, and you're going to get the same equation of a line. That's kind of weird. In fact, I could choose any point that lies on that line. Any point that lies on that line is going to give me the same equation of that line. That's kind of cool. Which one would you rather pick, the negative 4, 3 or the 2, 6? Yeah, the 2, 6. They're both positive, all right? But it doesn't matter. You can pick them either one. So let's pick the 2, 6. So what is the y then? Equals m, which is 1/2, times the x. What's the x? It's 2. And then plus b. Watch how easy this is. This goes to what? 1. Subtract a 1, so what's b? 5. Now, how do I write my answer? I've got a slope. I've got a y-intercept. Just put it all together. Y equals 1/2 x plus 5. And there you go. Now, that's in slope-intercept form, and we're good to go. Make sense? All right, it figures. When is this, 25? Yeah. Yeah, I ran out of time. I'll tell you what. Get yourself a head start on it. I don't know how far it goes, but get a head start on it. So it's pages 72, 73, and it's 1 to 33, but you're only doing the odds. Okay? Everybody see that? You're only doing the odds. Now, you probably will not get up to the end of these. There's a thing that we're going to do about perpendicular and parallel lines. Everybody hear me? So when you see them talking about perpendicular and parallel lines, that's where you could stop. But do everything up to there. I don't know what number that is. Anybody have the book open that could tell me? 27. So all the stuff we did today goes to 27. All right. So let's do this. Let's revise this a little bit. Let's go 1 to 27 odds, if Julia's correct. All right. And then that'll be actually due on Tuesday. Yeah, we'll call it A. We'll call it 2, 3A. Okay?